Graphs of increasing and decreasing functions. Graphs of increasing and decreasing function. The first one is monotonically increasing. The graph of monotonical increasing function is this graph represents a monotonical increasing function, that is y is equal to f of x. Y is equal to f of x, the graph represents monotonical increasing at the points x equal to a, x equal to b, x equal to c, x equal to d and x equal to e. And next one is monotonically decreasing. Monotonically decreasing. This graph represents monotonically decreasing. And next one is strictly increasing. The strictly increasing graph is, this graph represents strictly increasing, and next one strictly decreasing. The graph represents strictly decreasing. And next one, go to another definition of increasing and decreasing. Let f mapping from A to B, let f mapping from A to B be a function defined on the neighborhood capital A, neighborhood capital A of a real number small a that belongs to capital A. Let f be a function defined on the neighborhood of capital A of a real number small a that belongs to capital A is said to be, f is said to be increasing. F is said to be increasing if x less than a, it implies f of x is less than f of a. F of x is less than f of a. F is said to be decreasing when x less than, that implies f of x is less than. Here f of x less than f of a, f of x is greater than f of a. Here simply f of the function is said to be increasing function when x less than a, that implies f of x less than f of a is said to be increasing. When x less than a, f of x is greater than f of a, then the function is said to be decreasing. And next, another definition, let f be a function defined in the neighborhood capital A of a real number small a. of a real number small a that belongs to capital A. First one, if f dash a greater than 0, if f dash a greater than 0, then the function is said to be, increasing. If f dash a greater than 0, then the function is said to be increasing. If f dash a less than 0, if f dash a less than 0, then the function is said to be decreasing. Then the function is said to be decreasing. Simple definition of either increasing or decreasing depends on f dash x. Here f dash a greater than 0, then the function is said to be increasing. F dash a less than 0, then the function is said to be decreasing. Some examples about increasing and decreasing. F of x equal x e power x. Find the intervals in which the function is either increasing or decreasing. Find the intervals in which the function is increasing or decreasing. Suppose first one it is, first find the derivative, first derivative of the function, that is f dash x is equal, apply uv, that is x e power x plus e power x, that is e power x of x plus 1. Suppose if f is increasing, please find the intervals in which f of x equals square root of 25 minus 4x square. Find the intervals in which the function f of x equals square root of 25 minus 4x square is either increasing or decreasing. First of all, find the domain of the function. It is here 25 minus 4x square is greater than or equal to 0. 25 minus 4x is greater than or equal to 0. That is x square minus 25 by 4 less than or equal to 0. X square minus 25 by 4 less than or equal to 0. The factors are x plus 5 by 2 into x minus 5 by 2 less than or equal to 0. X plus 5 by 2 into x minus 5 by 2 less than or equal to 0. That means x belongs to open minus 5 by 2 comma 5 by 2. X belongs to close interval minus 5 by 2 comma 5 by 2. In this interval, for what value of x is increasing and for what value of x is decreasing. The next step, f dash x. Here f dash x, the given function is of the form root x. Derivative of root x is 1 by 2 root x, 1 by 2 root of 25 minus 4x square. 1 by 2 root of 25 minus 4x square, and its inner derivative is 0 minus 8x. Here 25 is a constant, minus 4x square derivative is minus 8x, that is equal to minus 4x by square root of 25 minus 4x square. Minus 4x by square root of 25 minus 4x square. And first condition is f is increasing. And first one is f is increasing. Here f is increasing means f dash x is greater than 0. F is increasing means f dash x is greater than 0. That is minus 4x by square root of 25 minus 4x square is greater than 0. Minus 4x by square root of 25 minus 4x square is greater than 0. That implies minus x is greater than 0. That is x is less than 0. Here the value of x lie between minus 5 by 2 and plus 5 by 2 and x less than 0. Here the value of x is lies between minus 5 by 2 and plus 5 by 2. Here the value is less than 0. Here the value is less than 0. Therefore, the function f is increasing. F is increasing in the interval open minus 5 by 2 comma open 0. Open minus 5 by 2 comma open 0. Show that the function f of x is equal to 7 minus 2x. Show that the function f of x is equal to 7 minus 2x is decreasing. Is decreasing on R without using derivative. Without using derivative. Show that the function f of x equal to 7 minus 2x is decreasing on capital R without using the derivative. Suppose let x1 comma x2 belongs to R. That implies x1 is less than x2. Consider x1 is less than x2. multiplying minus 2 on both sides, that is minus 2x1 is greater than minus 2x2, adding 7 on both sides, that is 7 minus 2x1 is greater than 7 minus 2x2, 7 minus 2x2, that implies f of x1 is greater than f of x2. Here x1 is less than x2, then f of x1 is greater than x2. Therefore, x1 less than x2, that implies f of x1 is greater than f of x2. Therefore, f is said to be decreasing. F is said to be decreasing function. F is said to be decreasing function.